Hello and welcome. Thank you for watching this video. In this video, we will see the concept of high availability and reliability in Azure. What we should know to architect any application for high availability and reliability. So we'll see the Azure infrastructure, what is meant by fault and update domain, availability sets and availability zones, also the difference between the zonal and zone redundant services that are present in Azure. So these are all important points for achieving high availability and reliability for your solution. So now let's talk about Azure infrastructure. So Azure Global Infrastructure is developed considering the redundancy and resiliency of application and data of the customers in mind. So hence this basically is made up of geographies, regions and availability zones, so which reduces the impact of failure and which is helpful for its customers application and data. So geography is an area of the world that contains at least one region. It basically defines a market that preserve compliance boundaries. For customers, compliance need is a really important part, and hence keeping their data within those boundary is important, which is achieved through selection of correct geography, and which will also be helpful for achieving the low latency as well. So you can consider that the geography is equivalent to your country. And in case of an Azure region, it is basically a set of data centers deployed within a perimeter and connected through a low latency network. And you can consider that within country there will be multiple regions, and each region is specific to a particular city in that country. In case of availability zones, it is basically a unique physical locations within an Azure region, that is within a city. So for example, one Azure is present in east part of the city, whereas other availability zone is present in west part of the city. So each zone has independent power, cooling, network. Hence, if there is a failure in one zone, it does not affect the other zone in other part of the city. So large flooding, storms, and other events could disrupt the site access, and it will have impact on that particular zone. So to get over this kind of failure, we will have multiple availability zones present in that particular city. So now we know how the Azure infrastructure is situated in different parts of the world and how it is managed for the availability. So now there are basically three scenarios which may impact virtual machines that are present in Azure. So there could be unplanned hardware maintenance events. So this happens when Azure platform predicts some failure in the hardware. So then it will issue an maintenance event to reduce the impact. The second is unexpected downtime. So this is when basically hardware for a virtual machine fails unexpectedly. So this can be local network issues, local disk failure, or even the rack level failures as well. So when it is detected, so Azure will take care and migrate your VM to a healthy physical machine in the same data center. And there is a third event that can happen is a planned maintenance event. So basically these are the updates made by Microsoft to the Azure platform to improve the reliability, performance and the security of the infrastructures on which your virtual machine is actually running. So these are the few events that can happen for your virtual machine. So now what exactly is availability sets? So it is a way to provide a virtual machine redundancy and availability. So you need to configure your virtual machines in availability sets to achieve high availability. So it protects and ensures that during a planned or unplanned maintenance event, at least one virtual machine is available for you. And with the availability sets, Microsoft Azure gives you 99.95 of percent of SLA. So within your data center, you have multiple racks which provides you virtual machines within the rack. So availability sets contain such racks which has independent power, network and cooling. So that they are not there will not be any single point of failure. And now each of these racks comes under a concept called as a fault domain, and there is a similar logical grouping as well known as the update domain, which defines the subset of your virtual machine which can be rebooted at the same time without affecting the other subset within another update domain. So these there are two logical grouping. One is for the fault domain and the second is the update domain. So each virtual machine within your availability set is assigned one update domain and one fault domain by Azure. So this design ensures that in availability sets, at least one of your virtual machines is up and running with the SLA of 99.95. So remember, one VM instance in availability set does not guarantee SLA, but unless it is used with a premium SSD or ultra disk for all your OS or data related operation. And if your single VM instance has standard SSD, then SLA is 99.5%. And if the single VM instance has standard HDD, then SLA is 95%. So that's what the SLA is for your single instance. So to achieve 99.95 SLA, so you should have minimum of two virtual machines that are present in availability sets. So for a given availability sets, five non-user configurable update domain are assigned by default, and which can be maximum of 20, so which indicates the group of virtual machines underlying hardware that can be rebooted at the same time. So when more than 5 VMs are configured within a single availability set, the sixth one is placed into the same update domain as first, seventh into the second one, and so on. So it is to be noted that order in which they are updated is may not be sequential, and we don't have control over it. So that's how availability sets can be helpful in ensuring that at least one of your virtual machines can be present, whether it is a planned maintenance, unplanned maintenance, or unexpected downtime as well. So to ensure this kind of availability, so you will have to create the availability set and place your virtual machines within that availability set. So internally, Azure will handle that by using fault domain and update domain. So when you create virtual machines, so it will internally assign one of the fault domain and one of the update domains to each of your virtual machines that are present in your availability set. But how exactly it creates and updates the fault domain and update domain to your particular VM when you create it? So let's take a look at in detail about fault domain and update domain. So a fault domain defines a group of virtual machines that are sharing the common power source and network switch and the other hardware things. But availability sets has maximum of three fault domains that you can have. So any operating system level failure or the application specific failure not covered by availability set. So it only limits any physical hardware failure, network outage, or power interruptions only. So, and in case of update domain as well, so basically it ensures that whenever there is a planned maintenance, then in that case your virtual machines are not rebooted all at a time. So to update only the subset of virtual machines that are present in availability sets, to ensure that at least one is available, you will have update domains that Azure will handle. So, but basically now in this example, let's consider that you have basically 12 virtual machines that are needed, and you have created three fault domains, which is a maximum limit. And for example, you have four update domain that you have created, and now maximum of update domains that can be created is 20. So now in this example, let's see 12 virtual machines that we are creating, and update domains are 4 and fault domain is 3. So now when I create first virtual machines, then by default it will be assigned a fault domain 1 and update domain 1. When I create a second one, it will go and create the virtual machine in fault domain 2 and update domain 2. So now it is ensured that VM1 and VM2 are using different power, different networking, and they are present in different racks present in the data center. Now when I go and create third virtual machine, so it will create the virtual machine in fault domain 3. So now we have 3 VMs and 3 racks present, and 3 logical grouping under update domain 1, 2, and 3. Now let's say I create a fourth VM. Now the fault domains are over, so we have only 3 fault domain, but now it will go and create the, on the fault domain first one. So now the fourth VM will be present on the fault domain 1, and the logical grouping will be update domain 4. Now if I go ahead and create a fifth virtual machine, so now it will create a fault domain 2 and update domain 1, and this is how it will be created for all of the 12 virtual machines. So VM6, VM7, VM8, VM9, VM10, VM11, and VM12. So that is how the distribution is done for against fault domain and update domain when you create virtual machines. Now if there is any failure in one of the rack, let's say there is a failure in fault domain 1, so that means your VM1, 10, VM7 and VM4 are not up, so you will have VMs present in fault domain 2 and 3 up and running. And now second scenario is there is a planned activity, and the system needs to be updated, and then they will be rebooted. So Microsoft will ensure that VM1, VM5 and VM9 can be rebooted at the same time, so that the below 9 virtual machines will not be impacted. So once the update domain 1 is done, then it will go and just reboot or update and reboot the VMs present in update domain 2. But the sequence is not clear. I mean, it can be update domain 1, it can be update 3, and it can be update domain 4. So that we don't know, and we don't have any control over it. But it will ensure that at least one of your virtual machine is present in fault domain and update domain. So we talked about availability sets. So now let us understand what is availability zones. So as we discussed earlier, so availability zones are unique physical locations within the Azure region that have independent power, cooling, and networking. So zones can be used to spread a solution across multiple zones within a region, allowing your app to run even if there is a zone specific failure. And availability zones basically offers you 99.99% of SLA, unlike 99.95% of SLA in availability sets. So the data and the application is replicated across availability zones in a synchronous manner. By this you reduces the data center as the single point of failure, because your data is now present in multiple data centers present in the availability zones, and these zones are generally tens of miles apart from each other within the city. So whenever you have a zone specific failure, so you can switch back to a different zone which is near to that particular availability zones, so that there will not be a problem with the latency as well. So your data will have the low latency as well, so even if there is a failure, so you can just switch back to the second availability zone. So we discussed fault domain and update domain in case of availability set. So in case of availability zones also, you have fault domain and update domain present, but now the fault domain and the update domains are present across the zone. So you have one fault domain present in one of the zones, and the second one is present in the second zone as well. So now it is not specific to the particular data center, but now the update domain and the fault domains are present across the zones. So we talked about availability zones. So now let's talk about the zonal and the zone redundant services. So Azure service that supports availability zones are divided into two categories. So one is zonal and the second one is zone redundant service. So with a zonal service, the resource can be deployed to a specific sub-selected zone to achieve more stringent latency requirement. And the resiliency is self-architected by replicating applications and data to one or more Azure zones within the region. So you can choose specific zones for replicating the data and the application. So when you replicate that data, it is your responsibility to take care of that. So you can choose synchronous replication, or you can choose asynchronous replication. So when you want to choose high availability as your priority, so you are going to use synchronous method. If you want the backup or the storage and the cost advantage, then you are going to use the asynchronous replication of the data. The second service is basically a zone redundant service. So within this architecture, the Azure platform automatically replicates the resource and the data across multiple zones, and the high availability is the responsibility of Microsoft in this case. as it manages the replication. So as we saw in the zonal services, you are self-architecting the solution in a such a way that you are going to replicate it, and you ensure that the application is highly available. But in case of zone redundant services, it is the Microsoft's responsibility to ensure the high availability of your data or of your application. So depending on the categories, so there are services that are divided into zonal and zone redundant, but there are few resources that can fall into both of the categories. So as we saw this example where you are using the load balancer as an example, so in the zonal, you can see that you have the load balancer that is actually specific to each of the zone. So this is basically a zonal service. But in case of the second example, you have the load balancer, which is actually a zone redundant service. So the load balancer is the example of the service that can fall into both the categories. So depending on your need, you can use that. And the now second example, which is specific to zone redundant services, Azure Storage or the Azure Cosmos DB. So these are the services where the replication of the data and the high availability of the data is managed by Microsoft. So that falls into the zone redundant service. So there are multiple services that are present in each of the categories. So depending on your need, you can choose one. So now we need our application to be highly available, and we want that to be reliable as well. So whenever there is any failure, you want your application to be running up and running every time. So we can easily fail over to the solution. So now in this case, the reliability is a shared responsibility in case of cloud applications. So this is basically on a foundation of three basic levels. So one is resilient foundation, resilient services, and resilient applications. So resilient foundation is basically the infrastructure that the cloud provider provides, such as the availability zone, so that Microsoft provides, and there are resilient services that we just saw, and then there are resilient applications. So it is a shared responsibility. So when you are developing your application, so that need to be resilient in nature, so you need to architect those applications in such a way that you use resilient foundation and resilient services together to build resilient application. So it is kind of a shared responsibility. So it is not correct to say that whenever you are using a cloud services, that means you are highly available and highly reliable. But the thing is, you have to build application in such manner that it is actually architected in a such a way that it will be uh, reliable in nature. It will fail over in case of any failure to your application. So now let's take an example of how we can, achieve high availability and high reliability by using different options. So in this case, this diagram is telling you how you can create a solution which can be reliable in nature by using availability sets, and you can use regional pair as well. So you can see that the source region is region 1, where you have a internet facing application that routes the traffic by using traffic manager. So if the region 1 is available, then it will route the traffic to region 1. And now your application has a public IP address which can be then used to access the web application. So you have basically multi-tier application in this case. So you have web tier, you have the backend tier, and then you have the data tier as well. So in this case, your web application is basic web tier is deployed with one availability set, so you can route the traffic based on that. So you can see that the load balancer is used to route the traffic between web 1 and web 2. So you are using the availability set to ensure that whenever there is a local data center failure, even if web 1 is not available, you are using web 2 which is available. And similar architecture is used for the data tier and the DB tier, so where you are using availability set to ensure that at least one of your virtual machine or the database is up and running. So that's how you have ensured that the local data center failure doesn't affect your application. So now what if there is a region failure? So now availability sets does not guarantee any regional failure. So to overcome that problem, what we did is we have used or we have replicated our application in region 2. So whenever there is a region 1 failure, so you are now routing your traffic to region 2 by using traffic manager. So that's how you can architect your application in case of any local data center failure, or you can have a solution for the any regional failure as well. So that's all about how you can create an application which is highly available and highly reliable in nature by using Azure infrastructure and availability set, availability zones, and different services which are zonal in category or which are zone redundant services as well. So depending on your need, you can choose different options to create application in such a manner that are highly available and highly reliable. Thank you.